Hi guys, today we're going over chapter 3 section 5, find and use slope of lines. So the slope of a non-vertical line is the ratio of change in y, which is the vertical change, and the change in x, which is the horizontal change. You guys have seen most likely this formula quite a bit in algebra, but it's just time to remember it. Remember, m is the slope. So the formula of a line is y equals mx plus b for the slope-intercept for, and m is the slope. Now m is what you're solving for. You guys probably remember also rise over run. That is, let's say we start right here, we rise that much in the y, and then we run that much in the x. Remember, in a coordinate plane, if you go up or to the right, it's always a positive change, and if you go left or down, it's always a negative change. Keep in mind, if you move in that direction, you would have either a positive or negative slope depending on the line. Remember, rest over run is just the way of saying this formula, changing y over the change of x. And from the graph, you can actually see the rise in red and the run in blue, even though I drew on top of it. And the equation again, m is the slope. Okay guys, so I want you to remember this. A positive graph, which is this one right here, rises as moves right. So keep in mind, you either rise up, so positive, and run to the right, positive. Keep in mind, rise is the y, which is a positive, and the change in the x is a positive as well. So it's gonna be a positive slope. Keep in mind, if we go down and to the left, it would be a negative y over a negative x, which again simplifies to a positive y to a positive x. We're going to keep that in mind. A negative, we have rise, and then run, we have a positive y and a negative x. If we go down to the right, we would have a negative y and a positive x. So it's not going to matter which is negative, as long as one of them is negative, it's always going to be negative. Now, for the horizontal, in this case, let's pretend that this line is equal to 1. We can say that y is equal to 1 because we can climb 1, and then it's always going to be that number in that graph. And then this one is in undefined, means no slope. So in this case, let's pretend that this is 2. We can say that x is equal to 2 because it's always going to be, that slope is always going to be at x is equal to 2. Now guys, if you're having a little bit of a hard time, please memorize that, yes. But also, let me erase all this stuff to show you. If you guys imagine, let's say this is a mountain. You can imagine a little guy, they can climb up the mountain. They can go horizontally in the mountain. They can go down the hill in the mountain. But as soon as they hit this cliff, this little guy is just going to fall. So if it helps to just remember, if the guy can walk up and down the slope, it means it has a slope. Even if he can walk on it horizontally, that is the slope. That moment the little guy cannot walk, which in this case is the undefined, it's falling off that cliff. That is no slope, it's undefined. Please memorize that. Now this is the theorem, slope of parallel lines. In a coordinate plane, two distinct non-vertical lines are parallel if and only if they have the same slope. So any two vertical lines are parallel. What does this mean? To put it in different words. So I wrote down y equals mx plus b earlier. That is a slope-intercept form. That m, if it's the same in both lines, it will be parallel no matter what. So let's give this blue line a slope of -1. This red one is going to have a slope of -1 as well. Now it's going to have a different y-intercept and a different x-intercept, but if the slope is the same, it will be a parallel line. So this is our theorem. Slopes of perpendicular lines in a coordinate plane. Two non-vertical lines are perpendicular if and only if the product of the slope is -1, so opposite reciprocals of each other. Horizontal lines are perpendicular to vertical lines. So guys, let's give this an example. Let's say that this red line has a slope of, let's say 4, right? Now, for the blue line, remember, it's the negative reciprocal, so it's going to be negative, since this 4 is positive, and the reciprocal will be 1/4. It's always going to work that way for a perpendicular line. Now, if you can take a second to pause this video and answer these before we keep going, that'd be awesome. I'm going to go ahead and start. So, complete with sometimes, always, or never. The slope of a vertical line is never 0. It's undefined. And I ran out of space. I'm just going to leave it there. The slope of a horizontal line is always 0. The slope of a line that rises to the right is always positive. And the slope of a line that falls to the right is always negative. I meant to write always in that other one. My bad. Let's just fix it up. Now, if it helps, some people are visual learners. So the slope of a vertical line, remember the guy's falling off the cliff. Horizontal, he can walk. There's no incline, so 0. It rises to the right. And if it rises, it falls to the right. Just keep that in mind. If you need to draw it, please go right ahead. Alright, so let's find the slope of the line through the 2 points that are named. So let's just write in m equals y2 minus y1 over x2 minus x1. Please try to do these on your own, and I'll go over it in a second. Alright, so remember, you can name whichever order pair you want as 1 or 2. I'm just going to go ahead and name this entire row, this first row, as x1 and y1. And I'm going to name this entire second row to x2, y2, just for convenience purposes right now. But again, it doesn't matter which one you name, as long as you're consistent. So, y2, 5 minus y1, 4 over -4 minus -3. So 5 minus 4 is 1, and 4 minus -3 is -1. So we have a slope of -1. Awesome. Now for the second one, it's -2 minus -3, all of that over -1 minus 6. So we're going to get 1 over -7. I'm going to do C over here because I'm running a little bit out of space. So I'm just going to write C down here. We have now for C, -4 minus -4 over 3 minus 8. So -4 minus -4 is 0 over, then 3 minus 8 is -11. So it's just going to give us a slope of 0. I'm going to do D right here. We can say that is 9 minus -2 over -6 minus -6. 9 minus -2 is 11. And -6 minus -6 is 0. This is undefined. Remember, a fraction cannot ever have a 0. Never, never, never. It cannot be it. It is an undefined. If you plug it in the calculator, it will give you an error. So please remember, can never, ever, ever be 0 in the denominator. Okay, so here they want us to complete the table for R and S being parallel. I'm going to write R and S right here. And then R and T right here are perpendicular. So if R, this is about the slope, guys, just so you remember. Now the slope of R is -1/2. So if S is parallel to R, you can say that this one is -1/2 as well. And since R and T are perpendicular, we have to do the negative reciprocal, so it's going to be +2. Now let's work backwards for B. They give us that T is 1/6, and R and T are perpendicular, so we can say that R is -6, and S is -6 because R and S are perpendicular. Again, now they give us the slope of S. We know S and R are parallel, so we can write the same slope. And R and T are perpendicular, so we can do the negative reciprocal, so -5. We can do the exact same thing we did for C, for D. And then, now for example, they give us numbers. Remember, any letter or any number is the same thing as over 1. So, they give us T. It's perpendicular to R, so that means R is the negative reciprocal. It's going to be -1/A. And because S and T are parallel, we can do -1/A. Okay, the same thing for T. They give us the slope of T. T and R are perpendicular. So I'm just going to go ahead and do the negative reciprocal, 4/3B. And because S and R are parallel, I'm just going to go ahead and write the same slope, since parallel lines have the same slope. If R and S are parallel and R is horizontal line, what is the slope of S? Okay, guys, so they tell us that R is a horizontal line, so boom, there it is. They're telling us S and R are parallel. Boom, there's there is the line S. Now keep in mind, since that is a horizontal line for R, so that means a horizontal slope for R. The slope for R is 0, and because S and R are parallel, we can say that the slope of S is 0. If you can, please pause this video and take a second to write in to figure it out. Okay, so if K and N are perpendicular and N has a slope of 0, what is the slope of K? So N has a slope of 0, that means it's a horizontal line. And they're telling us that K and N are perpendicular, so they're going to make this perfectly 90-degree angle. And now we see that K is a vertical line. Because K is a vertical line, the slope of K is undefined. Now they're bringing in slope-intercept form of a line. This is the y equals mx plus b is the formula. Again, m is the slope as mentioned earlier. And b is the y-intercept. Guys, a y-intercept is when you have, just as a quick reminder, you have this graph. The y-intercept is any point on this line on the y-axis. Please keep that in mind. That is a b. They want us to find the slope and the y-intercept and then graph. Now in order to get the slope and the y-intercept, we can rearrange these equations, all three of these, into the slope-intercept form. So I'm going to go ahead and do that for A. So I'm going to move that 2x to both sides. I'm just going to subtract it. Get -3y equals -2x plus 6. And go ahead and divide by 3 all of the terms. So we're going to get y is equal 2/3x minus 2. So I'm going to do it by color. So I'm going to highlight the slope in yellow. and the y-intercept in green. So the slope is 2 over 3, and the y-intercept is -2. Now for the next one, it's already in that form, so we can go ahead and say that the slope is -1/4, and the y-intercept is +2. Now for the last one, I want you guys to realize there's no x. But if you want it, you could write 0x minus 3 to show that the slope is 0, because there is no slope in the other one, and -3 is the y-intercept. If you can see without having to rewrite it, that is great. But if not, that is okay too. Alright, now let's graph them. We have that first A. I'm going to do it in black right here. It's a y-intercept of -2, and we're going to rise 2, so 1, 2, and we're going to run 3. 1, 2, 3. We're going to 1, 2, 1, 2, 3. So this is line A. I'm going to do line B in red. We have a positive slope of 2. We're going to go down 1 and run 4. 1, 2, 3, 4. We're going to go down 1, 1, 2, 3, 4. This is our second line. That was terribly drawn. And then for the last line, we had y equals to -3. So because it's y equal to -3, I'm going to put a point right here at -3. That's the intercept. And it's just the horizontal line, because we also said that the slope was 0. Now they want us to write an equation that passes through the point -1, 1, that is parallel to the line with the equation y equals 2x minus 3. Now, parallel means the slope is the same, so our m is 2. We can say, guys, that is y equals 2x plus b. Now, how do we find that b? We're going to use the points that they give you, in this case, -1 and 1. We're going to plug them in to our equation. So the 1 right here and the -1 goes to the x. So 1 equals 2 times -1 plus b. 1 equals 2 times -1 is -2 plus b. And I go ahead and add that 2 on both sides, and I get that 3 is equal to b. Now lastly, all you have to do is plug it back in, and we get the equation y equals 2x plus 3, and now you have the equation of a slope of a line that is parallel to the original equation of y equals 2x minus 3. Now they want us to write an equation of a line J passing through the points 2, 3 that is perpendicular, this is important, to the line K with the equation 2x plus y equals -2. Now before I figure anything else out, I'm going to actually go ahead and rearrange it to see it in a slope-intercept form. Now that I see this, I see that our slope, original slope, is -2. So for our perpendicular line, it would be the negative reciprocal, so it would be 1/2 x plus b. Again, we're going to plug those points in for y and x respectively. So it's going to be 3 equals 1/2 times 2 plus b. We're going to get 3 equals, we're going to get 2 over 2, so that's just going to simplify to 1 plus b. We're going to subtract the 1 on both sides, and I get 2 is equal to b. We're going to plug that into our original equation right here, and we're going to get y is equal to 1/2 x plus 2. Now we have the equation of a line that is perpendicular to that line K that passes through the points 2, 3. Alright guys, for the last example in the notes, they want us to find the distance from the point 1, 0 to the line y equals -x plus 3. Now, I want to make you guys understand that to find the slope of a line, due to the distance formula, we're going to take it into a few steps at a time. The first step is to find the slope. of a line perpendicular to the given line. Now in this case, the slope is -1 right here. So our new slope is m is equal to 1. The second part of this is to find the b. And we do this by using the y-intercept, what we have been doing from before. We get y equals 1x plus b. So we're going to plug in the points 1, 0. 0 equals 1 times 1 plus b. 0 equals 1 plus b. And subtract it, and we get that -1 is equal to b. So we have this our new equation, y equals x minus 1. Now, step 2 is find where the lines intersect. And I'm actually going to do that in the next slide. Okay, so we were left in step 2. We're going to do it by solving the system of equations. So we have the original y equals -x plus 3 and the one we made of y equals x minus 1. So we can do it one or two ways. We can do either substitution or we can cancel things out. Now in this case I'm going to do substitution. I'm going to do the substitution of the y's. So I'm just going to write -x plus 3 equals x minus 1. I'm going to subtract the x from both sides, and I'm left with -2x plus 3 is equal to -1. I'm going to subtract the 3 from both sides. I'm left with -2x is equal to -4, which then the x is equal to 2. Awesome. So now that we found this, I'm going to go ahead and use this equation right here, y equals x minus 1, and plug that 2 in to find its coordinate pair. 2 minus 1, y equals 1. So now we know that at 2, 1, the perpendicular lines intersect. Now we're going to use the distance formula. So we have the points 1, 0 and the points 2, 1. 1, 0 are from the original problem, because that's the point that they want us to find. And we found the point 2, 1 is where the lines meet. So we know that is a true. Keep in mind, when the lines meet perpendicular, we found this point right here. So we know that is a solution. And we're using the original points of the equation. Now, let's write in the distance formula. And let's plug it in. So the distance is, I'm going to name this my 2's and this my 1's. 1 minus 2 squared plus 0 minus 1 squared. D equals 1 minus 2 is -1 squared plus -1 squared. It's going to simplify to 1 plus 1. It's going to simplify to the square root of 2. Now this will be good as your answer because this is the simplest radical form. You don't need to do anything more than that. That is the simplest form that you can leave it at, and that would be an acceptable answer. You guys do not have to put it in decimal forms at all. Now this is it for today. Thank you guys so much. Awesome.